So in last two videos it is clearly described how this 90-degree phase shift appears between voltage and current while we talk about inductor and capacitor, or how a phase shift happens on describing the working of inductor and capacitor. So unlike in your lower classes, when you get into your higher classes, it is very much important that to represent a voltage or a current along with its phase angle. Not only the magnitude, the phase shift or the phase angle has also importance while representing the voltage and current. This is the point where complex representation is needed. That is, complex representation generally has the magnitude and the phase being expressed in its form. And you have two types of complex representation. They are polar form and rectangular form. General representation of polar form is r angle theta, where r indicates the magnitude and theta indicates the phase. And general format of rectangular form is a plus jb, where root of a square plus b square indicates the magnitude and tan inverse of b by a, or the imaginary part divided by the real part, will give you the phase. For example, let's take the case of inductor itself. It says that current lags voltage by 90 degrees. So if voltage is equal to 5 angle 30 degree, which means 5 is the magnitude and voltage starts at 30 degree. Now I have to mark for the current. So magnitude is independent, you can have any magnitude. Let us take 3 ampere, and it says current is 90 degree behind the voltage. So 30 minus 90, which is equal to minus 60 degree. So I can say I is equal to 3 angle negative 60 degree. Or if V is equal to 10 angle 90 degree, then I can say that I is equal to 5 angle 0 degree. So this is the case of an inductor. I can explain for the capacitor as well. If V is equal to 5 angle 30 degree, then current will be I is equal to 3 angle, that angle will be 30 plus 90 degree, because the current value is leading the voltage by 90 degrees. So it is 120 degree. So 3 angle 120 degree. And for another set, V is equal to 10 angle 90 degree, then I will be 5 angle 180 degree, 90 plus 90 degree. Okay, so you can have any magnitude. I have taken just 10, 5, 3, 5, etc. as random. Now, all this is a polar form of representation. A polar form of representation of this complex numbers. Now let's see how to get a rectangular form, or how to convert this polar form to rectangular form. Let's take this set as an example. We have to convert this into rectangular form, that is A plus JB form. Let us convert this voltage value first. That is, it is clear that the magnitude is 10 voltage and the phase is 90 degree. So root of a square plus b square will give you the magnitude, which is 10, and tan inverse b by a is equal to 90 degree. So from this expression it is clear b by a is equal to tan 90, and tan 90 is infinity. That is, a should be 0 there. Putting in the first equation, you will have root of 0 square plus b square is equal to 10, or root of b square is equal to 10, b is equal to 10. So now a plus jb becomes 0 plus j 10. It is 10j. So when this is v, let's see the corresponding way of representing the current also. That is, I is equal to 5 angle 0. The magnitude is root of a square plus b square is equal to 5. And the angle or tan inverse b by a is equal to 0 degree. That is, b by a equal to tan 0, which is 0, which means b equal to 0. Substituting over here, we get root of a square is equal to 5, or a is equal to 5. So the format a plus jb is just 5. This becomes your current representation. Let's take the other set as a next example. For the capacitor, 5 angle 30 degree voltage. This is the case of a capacitor. Let's see, root of a square plus b square. While I represent the voltage, This one, 5 angle 30 degree. Root of a square plus b square is equal to 5 and tan inverse b by a is equal to 30. So b by a is equal to tan 30, which is 1 by root 3. So b root 3 is equal to a. Substituting over here, you get root of a is b root 3. So b root 3 the whole square plus b square is equal to 5. Or root of 3b square plus b square is equal to 5. 4b square under root is equal to 5. 2b is equal to 5. b is equal to 2.5. Which means a is equal to 2.5 root 3 will be your a. Now the format a plus jb is 2.5 root 3 plus j 2.5 is the voltage representation for this set in a capacitor. Now the corresponding I value, it is 3 angle 120. So root of a square plus b square is equal to 3 and tan inverse b by a is equal to 120. b by a is tan 120 or b by a is tan 90 plus 30. At 120 degree, tan has a negative value, so b by a is negative. Complementary angle is cot 30. You get b by a is equal to negative root 3 or b is equal to negative a root 3. A square plus negative a root 3 the whole square is a square 3. 3a square is equal to 3 or root of 4a square is equal to 3. 2a is equal to 3, a is equal to 1.5. Now the format a plus jb, a plus jb is equal to 1.5 plus j, that is negative 1.5 root 3 j is equal to I value. You can even convert a rectangular representation of 5 plus 10j. If v is equal to 5 plus 10j, this can even be converted to polar form. How? Polar form means r angle theta, where r is the magnitude, so it is root of a square plus b square. So r is equal to root of 5 square plus 10 square, which is 5 root 5, and theta is equal to tan inverse b by a, that is 10 by 5, which is tan inverse 63.43 degree. So the polar representation of voltage is 5 root 5 angle 63.43 degree. So in any manner, this polar can be converted to rectangular form. Also rectangular can be reversed to polar form using this mathematical ideas. This can be easily done in your calculators also, which will be described in the next video coming up. So hope this video has cleared you how this voltage and current has always accompanied the phase along with its magnitude. If you like the video, please do like, share and subscribe the channel. Till we meet in the next class, this is Meenu signing off. Thank you and take care.